Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alif Nabil bin Yusuf. Today, I would like to present my subject, Integrated Design Project. So, this is my project. I was asked to take part in soil erosion and sediment control (ERCP) plan. So, this is my organization chart for my group. The total student is 9, and they are 4 department. So first is earthwork, second is soil erosion and sediment control, and third is water reticulation, and last is cost and estimation. So in our department, which is soil erosion and sediment control, I was working with my member Idham Fahmi. So what is soil erosion and sediment control? In this topic, we implement a various of design to control and remove the sediments from runoff. So it is because of the development area always cause a huge number of sediment delivered to waterways. So the problem can be solved by design and control the erosion and sediment based on MASMA. So the objective of this design is we want to maintain the quality of the water and to reduce the economic cost of erosion and sediment. So this is my flow of process in our department. First, we design a temporary drainage design. Next is soil loss estimation. Next is sediment yield, and then sediment basin. And then the other control is wash bay, silt fence, and hydro seedings. So we move to our first theory, surface runoff water. So surface runoff water is the flow of water produced by raining and flow from higher ground to lower ground. So by the theory, the flow can be estimated by catchment area. Next is earth drain. The function of earth drain is to divert the water flow to reduce the erosion and prevent leaking slash at catchment boundary. So the next theory is catchment area. By definition, catchment area is an area of land intercept the rainfall and transport it to the stream. Catchment area is also an area of land where water collects when it's rain. As the catchment collect rainwater, it will flow over the landscape and find its own way into stream and create river flow. The method we create the division is the every catchment is made at the highest point of the particular section. So next is sub catchment area. Sub catchment area is not compulsory to do this, but we use it to create the model for runoff water. And we assume that for each sub catchment has own hydrograph and routes to the lowest downstream, and it can be used to estimate the amount of waterfall into the sub area. So this is our catchment area and the sub catchment. So there are total of 6 catchment area in our left side, and each of the catchment we divide it by 2 sub catchment. So as example at our right side. So move to our first design, which is the design temporary earth drain. So the function of this design is to divert runoff to prevent erosion by directing the water flow and to reduce erosion and sedimentation. So in the next slide, I will explain how this design this temporary drainage. So first, we have to get our time concentration TC first. The time concentration is time needed for water to flow from the most remote point in a subcatchment to watershed outlet. So there are two formula in determining the time concentration. First is time travel for overland flow, and then the second is drain flow. So this is the formula we use in our design. So in this slide, I will explain how we calculate the time concentration. So I take subcatchment A1 as example. So the first thing first, we have to get the area of the subcatchment, and then we have to obtain the length of overland flow. Then we have to obtain the highest and lowest value and the height difference. After that, we can calculate the surface slope of this subcatchment, and then using the previous formula, we can calculate the overland flow and flow length, drain flow. So in total, we can calculate the concentration time TC. So to calculate the peak discharge flow, we have to determine first the average intensity. Average rainfall intensity is the relationship between rainfall, measure the duration of rainfall over time. Intensity rain is measured in the height of water layer covering the ground in the period of time. So we use location of Johor Bahru and taking 0.25 years of ARI. So this is our coefficient to be used in rainfall intensity. We have to calculate the peak discharge of flow. So using the formula, Q peak equal to CIA dividing by 360. So C is the runoff coefficient, I is the average rainfall intensity, and A is area of catchment. Our selection of drainage design. So in this design, we choose trapezoidal hydraulic section. So the design is based on the best hydraulic section, which is BHS. The advantage and why the reason we choose this section is this section of shape can withstand larger capacity of water flow and has a mild slope and easy to construct. So this is the overall result of drainage. Lastly, at the end of the result, we have to calculate fraud number, whether it's more than 0.8 or not. The soil loss estimation is the degradation due to erosion, desertification, salinization, acidity, and other factors. They are we have using the design and calculate this to estimate how much the soil eroded and can decrease the amount of storage capacity of sediment basin or reservoir. So we use this formula: A equal to C times L times L times K times P. So this formula can be used in the next slide. So first, we have to determine the soil erodibility factor of K. So this factor is to measure the susceptibility of soil particle to detachment and transport by rainfall and runoff. So soil erodibility factor is the rate of erosion per unit erosion index from standard plot. So below is the formula to calculate the K value. So next is the table for to obtain the coefficient to calculate soil estimation. So first is soil structure code. For our development project, the most of the soil is loam, so we choose loam as the soil texture, and the value of permeability code is B, and hydrologic soil group is B, and the soil structure code is 2. So at the right side is the table to obtain the LX factor. LX factor is depending on the slope length and the slope steepness. So by using of these two measurement, we can obtain the LX factor. So we can continue with the to get the average annual soil loss C factor. So in this slide, there are 3 tables to be used in our design. First, for undisturbed land. Second is for urbanized area, and last is for during construction site. So we can choose of the C factor based on the covering. Next is the sample calculation of soil loss estimation. So at first, as I stated before, we have to calculate the K factor first using the formula of K, and then we assume the rainfall erosivity factor R of each area is 15,000, and the K value, as we stated before, and LS and C factor and P value is from the table previous. So by multiply of this coefficient, we can get the annual soil loss. So by year, the total of soil loss is 428.98 tons per hectare per year. So at the end of the soil loss estimation, we have to calculate for existing site, uncontrolled and controlled condition. So we continue with the next design, sediment yield. What is sediment yield? Sediment yield is the estimation catchment as continuing of soil loss estimation. So sediment yield can be used to determine the storage capacity of sediment or traps design. So this is function when we want to predict the amount of sediment of sizing and sediment control. Below is the formula that we can use in calculating the sediment yield as stated below. So first, we have to determine the runoff volume. This volume can be get from our design of temporary drainage, as the design of sub-catchment that we use is the same. So to calculate runoff volume, we have to get the peak flow Q, and then times with the time concentration TC. So runoff volume is the total of peak flow times with time concentration. So this is the calculation of the result for existing condition. And then this is the result of uncontrolled condition. The formula is the same, that we use the same formula of sediment yield. And then this is the result for control condition. So in the next design is sediment basin. Sediment basin is the temporary ponds with control structure used on construction site to capture eroded soil. So the function of this design is to protect the water quality of nearby streams and neighboring properties from damage, and to prevent sediment from entering stream, river or wetlands. So this is our catchment area. There are total 6 of sediment basin. First, we draw a sediment basin at each catchment, and then the clean water is charged to the nearest flow. So in our design, we use dry sediment basin. Our development area has 6 different sediment basin. It was constructed before clearing and grading works begin. We use dry sediment basin because the development area major in soil type of sandy loam, as I stated before. So I will explain the procedure of design in dry sediment basin. Sediment basin consists of 2 components: settling and storage zone. So settling zone, we have to ensure that at least 0.6 meter, and storage zone at least 0.3 meter. So for most construction situation, the design storm should be of 3 months of ERI. So at the right side is the table that we use in analyzing the type of sediment basin. So this is the procedure of designing dry sediment basin. So settling zone is to contain runoff and allow suspended sediment to settle. Storage zone is to store the settled sediment until the basin is cleaned out. Sediment basin close downstream of disturbed land to trap sediment runoff. So at the right side is the procedure to get the dry sediment basin. First, we have to find TC for each catchment, and then use table 39.5 to determine surface area and total value. Next is designing the settling zone. Next is designing storage zone. Last is the next is to determine the sizing outlet pipe, and last is determining the sizing of emergency. So next is pipe outlet and emergency spillway. So spillway is for this sediment basin must be designed for 10 years of ARI. The purpose of spillway dimension will be 1.5 meter wide times 0.3 meter height. The sea level must be set a minimum 300 mm above the top level of the basin. To simplify the calculation, there are a few assumptions are made. First, we have to assume the riser pipe flow is orifice flow through the top of the pipe only. And second is riser pipe head is 300 meter mm. For example, the height between the top of the pipe and the spillway crest level. So below is the table of ERI coefficient that we use. So next is to determine the Q10. First, we have to calculate the ARI using the rainfall intensity, and then we have to calculate the Q riser using this formula. In our design, we follow just in the procedure that contained in MASMA. So this is the procedure that we use in our design. So this is the overall result of the basin. There are total of 6 basin, and this value can be used in the next design to get the dimension of or the cross section of sediment basin. So this is the result of the dimension. Okay, Lastly, we also include the other design for to control the sediment. First is wash bay. So wash bay is located at the access point of construction site. So the function of wash bay is to remove excessive sediment that are attached to the machinery. So how we design this wash bay dimension or the wash bay design? So first we have to list out the dimension of plant and machinery that will be used in our development project. So we taking the largest dimension of the plant and machineries and take it reference to design the project. So this plant has two lane which is to in and out, and then the water of the wash bay will be flow to the sediment basin. The other sediment control is we design of silk fence. Silk fence is the filter fabric to support the post, and it is not to filter the water. So this control can be considered if the area of catchment has small overland sheet flow. And by using this design, we have to make sure that this silk fence have to be maintained periodically to avoid damage. Lastly, we design of hydroseeding. Hydroseeding is a coat the soil that prevent erosion while we have a better site. So by limiting the soil disturbance and assist soil moisture. So that's all from my part for soil erosion and sediment control. I will continue with the other department. Thank you.